In looking at the encouragement for what we should talk about, I was led to giving a little background on my own research because it displays examples of things that all of us have dealt with in our scientific work: serendipity, the role of workshops, mentors, theory, experiment, all those things that, give us the adventure of being explorers and are independent of what science we do. My own adventure began probably as a 14-year-old with the launch of Sputnik, where America said, science and technology, I think they just got a lot more important. And so if you're interested in that sort of thing and you're a young student, that would be a good thing to consider. I was a very unsuccessful athlete as a young person, and so I had to look for other ways to feel okay about myself, and other than the traditional. And fortunately, I liked math and science, and so I was able to get on board with the idea that exploration might be a neat thing to spend your career with. And John Kennedy's speech to the Congress about going to the moon happened 2 weeks before I graduated from high school, and sort of confirmed for me that investing in a career in space exploration would be a wonderful thing to get to do. So I went to Vanderbilt and did physics, and then I went to Rice and did space science, just down the road from the place where the astronauts were preparing to go to the moon in the mid-60s. And it's been a wonderful, wonderful adventure. All of us have stories like this. We don't often tell our stories to the public, which is one of my points. We need to do that. Explorers, and many scientists don't even think of themselves as explorers. When we were growing up, we learned about explorers in history class, not in science class. And so we don't think, well, I'm not Christopher Columbus, so I'm not an explorer. But all of us are. All of us have had wonderful adventures in this, and we need to give that story to the public in an appropriate way so that they can appreciate it. I want to show you just a few things about my research, which I mentioned in the introductory part, is a little bit a larger view of the Earth and the climate and all than the majority of this group thinks about. This is a picture that represents what we thought was going on in terms of how the Earth's space environment is controlled by the sun when I was in graduate school. So this is a 1965-66 picture. The sun, very dominant, solar wind blows by the Earth, makes the Earth's magnetosphere change from a donut shaped into something that looks more like a windsock with a 1,000,000-mile long tail. And the thinking was that the solar wind plasma, H plus electrons, a little bit of He double plus, found its way into the Earth's magnetic field and filled it up with particles. The radiation belts and more esoteric things like the ring current and the plasma sheet, all these places. There was one weird thing, which was a very small area down close to where the radiation belts are that was filled up with plasma that, instead of being a kilovolt in energy, was 1 electron volt in energy. Looked just like the ionosphere. And it was thought to be some upward extension of the ionosphere without really knowing how that took place. This is what we thought. So I studied the plasmas. My PhD was about the aurora, the energetic particles. I was well on board with magnetospheric physicists who thought energy and not ionosphere. And I had this thing happen where I was working at Lockheed, and I was working on the aurora, and they ran out of money. So it just turned out that another person in the lab had built an instrument and flown it on one of the OGO satellites, and they had some data analysis money. And so my boss said, Rick, we're really happy about what you're doing, but we ran out of money on the aurora. Do you want to work some on the low energy plasma part of things in the magnetosphere? Given the options, that sounded like a great opportunity for me. And so I started studying this region down in here where the particles look like the ionosphere. And I'd go to AGU meetings, and it's called the plasmasphere. Looks like just like the ionosphere in terms of the composition, the energies. And so I'd go to AGU meetings, and one meeting I'd be in an ionospheric session, the next meeting I'd go and I'd be in a magnetospheric session. I was just in a time warp or a regime warp. And so we thought, you know, we should do something to try to get the magnetospheric people to talk to the ionospheric people. This is an AGCI type of thing. This was done in 1974 at Yosemite, where we had a Chapman conference. We brought together ionospheric scientists and magnetospheric scientists and let them learn from each other, teach each other, get interested in what each other was doing. And that got people to begin to think about how the ionosphere connects with the magnetosphere somehow. And so several things happened in that time period. A spacecraft that Lockheed built measured oxygen, O+, in the magnetosphere at energies of 1 to 10 keV. So 1,000 times the energy that it obviously came from the ionosphere with, because O+, you don't get O+ out of the sun, you get O6+, something like that. And so all of a sudden people were saying, whoops, the ionosphere must do something to fill up the magnetosphere. And so we tried to measure some of these things, particularly the low energy part. We built an instrument, put it on the Dynamics Explorer spacecraft. This is 1980. And we measured around the Earth, looking for stuff flowing up from the ionosphere to fill up the magnetosphere. Turned out there was a lot of it. This just shows every time the spacecraft spins and looks down, you see stuff coming up. And it also shows that you have to put some potential out in front of the instrument because the spacecraft charges positively and it can't see low energy positive things. They get repelled away from it. So it's hard to see this stuff. But it was there, and Peter Banks and Tom Holzer had predicted in early 70s that there ought to be stuff called the polar wind flowing out all the time. And the question was, where was it going? It looked like it could fill up the plasmasphere. That was a good thing. The question was, could it do anything else in the magnetosphere? So we measured so much of this stuff. This is the magnetosphere from the side. Here's the Earth. Here's the plasmasphere. Ionospheric stuff flowing up all over the place, filling up the plasmasphere. That was pretty straightforward. The question was, did it do anything else in the magnetosphere? These particles are leaving the ionosphere with just a few volts, electron volts of energy, and they sort of disappear when they come up in here because spacecraft that fly in this region where there's not much plasma get charged so positively that they can't see the low energy plasma coming up. And so we said in this was a 1987 paper, we said maybe it's up there and we just can't see it. Oxygen, helium plus, H plus, that moves somehow into the middle of the magnetosphere and gets energized to the point where we can see it. So all of a sudden it moves out invisibly. You can measure it down here, but you can't see it up here. Then it gains energy and is seen as something that looks exactly like the solar wind. It's really confusing. But you can look at its composition and tell something about it. So this was kind of a leap of thinking about what it might be, which today, 27 years after this paper, but 40 years after sort of this initial discussion of what the ionosphere did, seems to be, the paradigm slowly seems to be changing. If you look at the particles, once the models got better, if you look at them and they start with a few eV here, they go back, and when they get into the tail, after a while they're up to 1,000 eV or 10,000. They're becoming something else in the magnetosphere. The models got even better, and we found that flowing out away from the Earth was not just the polar wind, but a lot more energized particles that could go farther out into the magnetosphere and make these different regions. And very recently, within the past few years, the invisible particles have been found. This is a wonderful thing in science where you go looking for one thing, you can't understand what you've got, and you discover something you weren't even looking for by figuring out the noise in the signal that was there. And this is a European set of measurements that was, as the spacecraft spins, it would measure the distortion of the plasma flowing by as the electric field measurements went through it. And the wake of the spacecraft didn't look like it should. And they kept working on it to the point where they realized that's because there was a very large flow of plasma coming away from the Earth that then made this invisible plasma visible by looking at the wake. So there's the original picture, and this is today's picture, which is that the solar wind probably gives the energy to the magnetosphere, but the particles probably come from the Earth. So the sun, the solar wind streams by, distorts the magnetic field, energizes the plasma, but it's not the solar wind plasma that you see. It's plasma that starts in the ionosphere, moves up, and is energized. So this is an example of how our ideas about things change. I mean, we understand science the way it is at that point in our exploration, but it can change and paradigms often have to shift. We had the second meeting at Yosemite this past February. It was on the same subject. It was 40 years later after the first one on this subject. And it's now called magnetosphere-ionosphere coupling in the solar system, because this happens at Jupiter and it happens at Saturn, happens at many planets. But still there are people who are looking at that figure back in 1965 and are kind of stuck there. The paradigm change is often very slow. So let me just make then a couple, that's been kind of my history in terms of my research. Let me make a couple of comments about AGCI and particularly how we're doing. I'm an outside of climate science person, a very interested observer and involved, because people are always asking me, well, what do you think about global change and that sort of thing. How are we doing? I think that we're doing, despite all the discussion of the challenges that we have, and we have many, I think that we're doing well in terms of the continuous public awareness of global change, a growing public understanding. It's slow, but it's coming along. Lots of measurements, mission to planet Earth and the satellites from so many of the different other agencies are doing, they're giving the right stuff, and the models are coming along extremely well. It depends on administration, of course, and it's amazing the leadership, how the leadership difference. I was involved in working with Al Gore on the GLOBE program that Sherilyn mentioned, and of course his influence in terms of awareness of the environment, the need to understand it, the need to make the right decisions, Earth in the balance, inconvenient truth, all of those things are extremely important in terms of public understanding. The Bush era, I won't even go into, but the thing that I think we have such a challenge on is the people who drink the poison, or people who get their science from Rush Limbaugh, or people who get their science from Fox News. Incredibly confusing, to the point that I have friends who are very, very intellectually sound people. They're MDs, they're PhDs in engineering. These are people that do numbers, they use science in there, and they don't get it because they get their science from Fox News. Incredibly powerful negative confusion that we're just gonna have to keep pounding away on giving the right information and doing it in the right way, like was talked about earlier. So in terms of AGCI, interdisciplinary get-togethers are extremely important. They always have been and they always will be. Teaching each other, that opportunity is wonderful. We need to keep doing that. The communication side of things is so incredibly important. And I think there have been several suggestions about things we can do there to fine-tune our ability to overcome the Fox News machine, and get people the right information so they can make their decisions on that. And I would encourage, as I started at the beginning, I would encourage people to think about your own personal story. I mean, you've got it. Everybody here is an explorer with an incredible adventure that we've lived. Think about your own. Think about telling that story in different circumstances. And then I think AGCI can play a role in doing both the big picture communication about climate science, but also the individual personal communication about the people who do the climate science. So I'll stop there.
So we've got 4 minutes for questions. Sherry?
So this illustration is a beautiful opportunity to talk about the importance of education and communication research, because diagrams that we kind of take for granted, I'm in this domain too, right, with you, Rich, that's my fundamental background is in solar physics. And we did research when we did a traveling exhibit to science centers on this topic, right, of the aurora and space weather and solar wind and all of that. And we showed them, they come out of the exhibit and we show them this picture. And we would say, point out the Earth. A very large percentage, well over 50, it may have been as high as 80%, couldn't find Earth in the image. It didn't, and it's just not familiar graphically with what's going on there. Also, we found that it connoted a problem with scale. We use these beautiful diagrams, and we have to take care that it's giving the wrong impression, right, about the scale. And we learn this when we actually ask the people that we're trying to reach, and we were totally shocked. It's like, what? You can't find? I mean, look, it's blue. It's right there. It's that little, no. And so some things that we think are obvious about our explorer's story, right? Sometimes we think it's obvious, and it's maybe not so much so. And it helps to have some kind of longer-lived partnership where you can ask somebody, right, to develop your ability to tell your story in a more effective way.
Yeah.
Well, here we will talk about biases and framings, right? I mean, it struck me because I always have been passionate about philosophy of science, how you describe this shift in paradigm, and of course, I'm biased. I see the Earth, right? But this shift from the Earth being like a passive receptor of whatever the sun is providing to being an active element that interacts, and there are feedbacks in the relationships, etc. So, I mean, it also struck me what she pointed to, but I think that for us, I mean, many of us understand this, for us, these two figures were very telling, but I see your point that outside our community, that might not be the case.
It connotes much more than we intend. Partly what we intend, and much more beyond what we